And you have a search where you're saying, okay, we want something that's not a natural signal.
Right.
But we don't know for sure what every natural signal looks like, which has got to be part of the processing challenge. And then I know for a while people were looking at, your group too, at H1, at 21 centimeters, where you would have a line from atomic hydrogen at that wavelength, because the idea was, well, everybody knows the universe is made of hydrogen, so maybe people would talk to us in some way.
Yeah, but we don't transmit at 21 centimeters because it's protected. No.
Well, I mean, maybe yes, but also, in other words, that's not a natural thing that people would do in our technological society. We don't use 21 centimeters for some special reason.
Well, we don't use it. We protect it. Right. We actually don't want any transmissions at that frequency so that we can study the universe.
Right. And so actually, other societies might do that too.
Yeah, but general. Right. There is a region of the radio spectrum that is relatively quiet.
Right.
We call it the terrestrial microwave window.
Right.
And so we try and, in fact, observe throughout all of frequencies from 1 to 10 gigahertz.
Right.
And so rather than picking magic frequencies, we just look everywhere in that band.
And so that, to go back to this theme of ignorance, right, is you're not trying to be specific about, where somebody might talk to you, because you're not really looking necessarily for somebody who's purposely trying to signal us. You're just looking for signals that could be from somebody else.
Yeah, we're looking for the sign of technology. So we're looking, when we look in the radio, we're looking for frequency compression. We're looking for signals that are, as far as we know, too narrow for nature to produce.
Right.
But we can do that with transmitters. In the optical, we're looking again, frequency compression. We're looking for for laser signals at a unique frequency, or we're looking for time compression, a pulse that lasts for a nanosecond or less. And a nanosecond, light travels a foot. Right. You can't get enough atoms and molecules in a cubic foot of material out there to produce a detectable signal.
Okay.
Right. So, but you could do it with a laser and a large telescope. So we think that time compression and frequency compression are good indicators of something that might be engineered.
Reading about the John Snow Cub.
Learn more at predictionx.org, where you can stay up to date on all of our latest offerings and interviews.